Hey, I'm Muneeb Rasool, and I have Michael Jacobs with me, co-founder and CEO of FermiHDI. Mike, it's an honor to have you with us. Maybe tell us a little bit about yourself and what you do.
Thanks, Muneeb. It's a pleasure to be here. I'm excited because we're finally coming out of stealth and our hyperscale data infrastructure software is set, I think, to make a big impact. So a little bit about us. We got very frustrated working with large scale data, which I know you're very familiar with your solution, but we see it in AI and machine learning and data science. And what we see is the industry basically buying Ferraris and putting them in the data center. And that is, it's a way to go faster, but it's incremental. What we really need is a way to solve the data problem, which feeds all of those servers and chipsets and RAM, et cetera, with a better data system that is not running the Ferrari on a dirt road with potholes, but instead a Formula One track, and so they can all go faster. So that's what we're up to. We're building a more efficient way to use less resources for this data set and still achieve the performance we need.
So, Michael, when you talk about hyperscale data sets, what makes them different from traditional data or standard data that's being used in the enterprise today?
Sure. So unlike when we change your phone number in a CRM database, hyperscale data sets are typically coming in constantly, typically machine generated, and sometimes from IoT, sometimes from large data sets that come in lumps, like radiology images or things like that, AI data sets. But they're over 1 billion records, which it's a big number, but really it's 10 terabytes, not that much, easily ranging into petabytes of data, all the same data set. And we have a lot of ways that we try to deal with that scale of data today. And we've got, as you can imagine, all the crutches are there in the system, but you can only take a 60-year-old design, which is our file system fundamental, and get it to go so fast. So we really needed something fundamentally different to handle this scale of data.
So you talked about unstructured data, like you mentioned radiology images or video and audio data.
Right.
So how does your company, your solution handling that data differently?
We feel that there's a bit of a misalignment in understanding for what that data really is. So when you and I look at an image, we see a picture of the car. The computer doesn't. If you want that computer to actually process the image and do anything with it, like find what the driver's face looked like or find the handle for the door, it's looking at vectors or some other fixed data. That data, just like any other data, is structured when it's put onto the system and processed by the computer. So we work with it just like any other data set at scale. So there's really, from a machine perspective, no such thing as unstructured data.
So Michael, you said that the file system is an overhead.
Yes.
So what is FermiHDI solution that can take care of this massive data without a file system?
That's our fundamental breakthrough. So the file system at a very high level, just simplistically, is taking a series of records that it receives and encapsulating that in a file structure as a concept. And then it stores that randomly on a drive, which we retrieve at some point when we want to go look at it. And that's fine for smaller data sets. But when we start talking about larger ones, remember, we have to retrieve the file into system memory and open that file in system memory, and then provide our first filter, which sorts through the records that were in the file. And we have to do this over and over and over to get through that larger data set. So it just takes time. It may be only milliseconds every time, but when you have a petabyte, it adds up quickly. What we've done that is fundamentally different is we got rid of the file system. We got rid of that overhead completely. So what we do instead is we store the data as records on the drive linearly, and then when we have a query, we send that query down to the drive level, and as we read the data on the drive, we're actually performing our first filter in that process. So we're able to send the results only out from the drive through the network to the next service. So a data processor to do vector math or graph, algebra, relational algebra like SQL, which are separate services, now receive a stream of data, and it's hyper efficient. We get rid of roughly 90% or so of the overhead of systems from file structures by doing it this way. And that's where the speed up comes, and that's what frees up all of the resources, because we're not using system memory to do it, RAM, and we're using virtually no other resources. It's just number of CPUs that we need for cores and how fast is the drive.
Wow. So that's how you turn a commodity server into a supercomputer.
That's the plan.
Yeah.
And it works.
Very cool. Can you give us a real world example of this performance leap?
Sure. We have a deployment that we did for a manufacturer, and they make a superconductive tape. It's a very expensive process for a very expensive material. And they use a bunch of sensors to send a huge amount of data back to the data science team to optimize that process, to make sure that their quality is correct. So quality assurance is number one, but also to build it faster and more efficiently is key. So as you can imagine, this is a lot of data, and they're running this query over 90 days. They run it every day. And that query would take up to 8 hours if it returned an answer at all. So on the same hardware, we ran our system as the back end for the data, and we brought that query from 8 hours down to 5 to 8 minutes on the same old 5-year-old server. So a radical leap, because it dramatically changes their operational cadence every day, and the improvement in just knowing it's going to be received, actually getting an answer every time consistently, is a big deal.
So Michael, looking forward, what is your vision for the next 3 to 5 years in the enterprise data architecture?
I think it's very straightforward. We want the hyperscale data infrastructure to revolve around using fewer resources, generating less heat, using less RAM, fewer servers to accomplish the same tasks, or go faster even, to scale with the growth rate of data today, which is exponential every year, and to do it seamlessly. Because at the end of the day, we're using so many resources already, those Ferraris aren't getting cheaper. So I think that's the short-term goal. Long-term is, how do we extend our solution into other areas? You know, what other areas use RAM? Well, KV cache and a whole bunch of other things. So it's a very big idea for us. And I think that the impact on the market and on data centers, space, power, and cooling will be massive.
Very cool. Well, Michael, it was such a pleasure talking to you, having you with us. Thank you very much.
Thank you. Appreciate it.